In this video, we will explore the concept of abstract classes. It is a concept that many students find challenging, especially why we should use abstract classes in a class hierarchy design. Let's look back at our shape hierarchy from the previous video. Assuming we want to implement a class containing a collection of shapes and compute the total area of the shapes, we need several lists. One for the circle object and one for rectangle and square object. If at a later stage we implement another type of shape such as polygon, triangle for example, we must refactor the code to add a new list containing the polygons. This approach is not future-proof and will create issues for software maintenance and updates. It will be much better to have only one list of shaped objects. However, we have seen that if we store a set of rectangle and square within an array of shapes, we were not able to use the getArea method as the compiler throws an error. A possible hack is to add a dummy method getArea in the class shape, like so. We must trust that all implementation of subclass of shape will override the getArea method. Overriding cannot be enforced this way. This is a clear source of issues in future maintenance of the code. This is definitely an unsatisfactory solution. A better solution is to use an abstract class. An abstract class is a placeholder in the class hierarchy that represents a generic concept. We use the modifier abstract on the class header to declare a class as abstract. An abstract class cannot be instantiated, meaning I will not be able to create an object shape with a constructor shape. An abstract class often contains abstract method with no definition. That is, the method header is directly followed by a semicolon. The abstract modifier must be applied to each abstract method. Usually, a method is declared abstract when we do not have enough information to compute the result of this method. For example, there are no general formula that can compute the area of a general shape. The formula to compute the area of a rectangle differs from the formula to compute the area of a circle. Therefore, we cannot write the computation of getArea within the class definition shape. We must delay its implementation. An abstract class typically contains non-abstract method with bodies. A class declared as abstract does not need to contain abstract methods. The child of an abstract class must override every abstract method of the parent, or it too will be considered abstract. An abstract method cannot be defined as final, because it must be overridden, or static, because it has no definition yet. The use of abstract classes is a design decision. It helps us establish common element in a class that is too general to instantiate. For example, the definition of a shape is very general, something very abstract in nature. Therefore, it's quite natural to find that this class should be abstract. In the next video, we will be looking at another important concept of object-oriented programming, the concept of multiple inheritance.